Hello, my dear kids. Namaskara. ಹೇಗಿದ್ದೀರಾ ಎಲ್ಲರೂ? Okay, coming back to chemistry. As you all guys know that the very first chapter of chemistry is mole concept, right? And when it comes to mole concept, usually it happens that it looks like a scary monster. Yes? But let's break that myth and let's crack the complex of mole concept. So mole concept, whether you take a physical chemistry part or an inorganic chemistry part or an organic chemistry part, whichever part of chemistry you take, if you don't know what is one mole, what is molecule, what is particle, what is atom, it is very difficult that you can crack the complex in chemistry with respect to whichever branch it is, right? So to know that what is this mole concept, before we directly jump into mole concept, we have to understand few more things there. I can say what are atoms, what are particles, what are molecules, what is Avogadro number, and there are few laws which makes it more easier for you to understand how we see the reactions, how this mole concept can affect different parts of chemistry. All right, let's get started. So the laws which I was talking about, the very first law, we can also call them as law of chemical combinations, right? Laws of chemical combinations. So what are these laws of chemical combinations? There are a total of 5 laws. So the very first one, law of mass of conservation, law of definite proportions, law of multiple proportions, Gay-Lussac's law of gases, Avogadro's law. Right? So these are the 5 basic laws of chemical combinations. Apart from these 5, when we talk about the competitors, whether it could be a NEET or it could be JEE, CET or UG or anything for that matter, we have another law which is again important, that is law of reversible proportions. Okay, so these are the 6 important laws which come under law of chemical combination. Let's check one after the other. So the very first law, law of conservation of mass. So law of mass of conservation of mass. You are listening and learning this from your 7th standard, that the mass can neither be created nor be destroyed, right? So here if you see, when coke is burnt completely in presence of air, it is going to give you carbon dioxide. So before the reaction, the mass of coke and the oxygen is 44, and after the reaction, that is again 44. So here we are neither creating nor destroying. We are just changing it from one form into another. All right. Okay. Now let's start and go for the second law, that is law of definite proportions. So what happens in law of definite proportions? So in law of definite proportions, so if you see here, let me take the same example again so that you understand it better. Carbon again is reacting with oxygen to form CO2. If I change the number of moles of carbon or oxygen, if I take some 3 carbon or some 6 oxygen or some 12 oxygen, and here if I write it like some C12O18, do you really understand, or do you have seen any of compound which is C12O18? No, right? When I say carbon dioxide, can I take any number of carbon and any number of oxygen? No. When I say carbon dioxide, when we listen carbon dioxide, it has to be 1 mole of carbon and 2 moles of oxygen. Then only we call it as carbon dioxide. Yes, so that is called as law of definite proportions. Clear? Okay, let's moving on to the next one. Law of multiple proportions. So what is this law of multiple proportions? So just what I said, carbon has to be on these many moles, oxygen has to be on these many moles. If I change that, what happens? If I write carbon and oxygen, let me take 2 moles of coke, and if I burn it, I can have carbon monoxide. That means when I change the number of moles, the carbon dioxide is now not the same. It is carbon monoxide. So whenever, if you have, let me rub this and explain it again. If you have 2 elements like carbon and oxygen, and they are giving you more than 1 compound, then this is called as law of multiple proportions. Clear? Simple, right? Okay. Let's go to Gay-Lussac's law of gases. The law itself says that it belongs to something which is gases. Here, this law is almost the same as your law of definite proportions. So here, just that we consider gases. When we consider law of definite proportions, so this law is for all the compounds, even if they are gases or they are solids or they are liquids or whatever. But when it comes to Gay-Lussac's law, it is particularly for gases, where the gases combine in proper ratio, proper proportions to form a new compound. Okay. Next, what is this Avogadro's law? Avogadro's law, yes, this is also related to gases. So what happens in Avogadro's law? So Avogadro's law, where the gases, any gas taken in same volume, any gas taken in same volume possesses same molecules or mass. Number of moles. Okay, so what is this? This means you can imagine a cylinder at your home. In that cylinder, which gas is present? Okay, so the gas is butane. So in that cylinder, if you fill that cylinder with hydrogen, or if you fill that cylinder with methane, or if you fill that cylinder with any of the gases, if the cylinder is of 15 kgs, you can fill any gas of 15 kgs only. Whether your methane has 5 atoms and different mass, hydrogen has 2 atoms and different mass, whatever it is, but when you fill it, the volume occupied by any of the gases will be same, and that is called as Avogadro's law. You can take another example, a balloon, right? So in that balloon, if you blow it with your mouth, the carbon dioxide, that the amount capacity of that balloon is same. Or if you fill it with the nitrogen gas or the hydrogen gas or whichever gas, helium gas, you take any gas, the balloon's capacity remains same, and the mass on and the moles of gases occupying in that space of balloon are also same. So that is Avogadro's law. So next, coming to law of reversible proportions. So what is this? So all these laws, as I already told you, are only for the board's part. Okay, so when we jump into little bit of extension towards competitive, we can also consider law of reversible proportion, or also call it as law of reciprocal proportion. What is this? Let me rub all these things. Law of reciprocal proportion, for example, let me take 3 elements, any 3 elements for that matter. So this is not actually applicable for all the gases, but very few gases are considered, gases or liquids are considered in this law. So let me take sulfur, oxygen and carbon. So now sulfur, oxygen, carbon, if I combine carbon and oxygen, it will give us carbon dioxide. Similarly, sulfur and oxygen, they can form sulfur dioxide, and similarly carbon and sulfur, they can form carbon sulfide. So this is called as law of reversible proportions, or we also call it as reciprocal proportions. So now you guys are aware of all the laws which are required for the reaction, right? Now let's start and understand what is this mole. So what basically happens in mole, what combination we call it as mole, what is molecule, what is particle, what is atom. Okay, so atoms are nothing but the elements, pure elements in their form in the periodic table. You have seen in periodic table, if you don't know, you can cross check. There are total of 118 elements in periodic table. So each element has its own atomic number. So according to their atomic numbers, we have seen in periodic table, they are arranged, right? So according to their atomic numbers, the number of protons and neutrons and electrons, we can also decide their masses, correct? And we can learn about these in depth in a different chapter called structure of atom, and also we'll learn about their chemical physical properties, what happens to their sizes and everything in periodicity. So here we will not touch that part, we will just keep it simple. So each atom has its own mass. So for example, if I take hydrogen, it has a mass of 1 AMU. This AMU means atomic mass unit. And similarly, if I take oxygen, it has 16 AMU. And if I take carbon, it has 12 AMU. Ma'am, how to remember these many masses? So there are only very few elements which you have to focus on. And if you have seen all the questions and everything in the chemistry, you'll come across the repeat molecules or the atoms for which you should know the atomic masses. And definitely if you message me that you need one-on-one session or so, I'll give you the notes and everything which is required to know about the masses which you need to remember. And yes, shortly we'll come across the trick to remember the masses. Okay, so these are few elements which you can remember. Similarly, so these are all atoms, right? These are only single atoms, and these masses are called as atomic masses. Okay, and similarly, if we take a molecule in the sense, it could be a carbon dioxide, it could be water, it could be hydrogen gas for that matter, or oxygen gas. So these are all molecule, and when we combine the mass unit of atoms in those molecules, they will give us, for example, CO2, carbon plus 2 oxygens. Carbon is 12, oxygens, there are 2 oxygens and they are 16, and they come up to 32, and total of this will come up to 44 AMU for carbon dioxide. Similarly, for water, hydrogen, there are 2 hydrogens, that means 2 plus 1 oxygen is 16, and it gives 18 AMU for water molecule. And for hydrogen gas, it is 2 AMU. And for O2, it is 32 AMU. And basically, while we are calculating, if you have seen, all these AMUs are mentioned in grams, and that is completely fine. So these are atomic masses, and then what are these called as? No doubt these are called as molecular masses. Okay, and now we will see what is this 1 mole. 1 mole is any of the compound which is 1 mole. 1 mole is 1 mole. Yeah. How? I'll show you. So let me take 1 mole of NaCl. 1 mole of NaCl, that is your table salt. Correct? Let me grab some salt for you. I have a salt. Okay. So when I say this table salt, NaCl is 1 mole, that means what is the atomic mass of Na? What's the atomic mass of Na? 23, right? And what's the atomic mass of chloride? 35.5. So together 1 mole of NaCl is 58.5 grams, or we can also say it as AMU, right? Okay. Now, when I say this 1 mole, when I weigh 58.5 gram, this is approximately this much, correct? Okay. So, in this, if I take a small pinch of the salt, okay, in this pinch, how many particles of salt are there? No idea. Can you count that? And let me take a very, very small piece, very small. Can you see this? Okay. So, even this is NaCl. It has all the characteristics, chemical and physical, which are present in this much of salt, correct? And now if you need to count this 1 mole, 58.5 grams, you will take a single particle and you will count it like 1, 2, 3, 4, 5, 6,000, 10,000, 20,000, 30,000, 1 lakh. How much they are? So practically proven, approximately taken. So this is equal to 6.022 into 10 to the power 23 Avogadro number of molecules. So this bowl is 1 mole and each particle in this is a molecule and they are total of this much. That is Avogadro number and this is called as 1 mole. Is it very clear? That's how we have to crack the complex. Similarly, there were questions like number of atoms, atomicity, right? So here if you see, Na is one atom, Cl is another atom. So in 1 mole of NaCl, how many atoms do we have? 2, right? 2 atoms. But in that bowl which I shown you, is it only 2? No. That means 2 into this Avogadro number is considered as Na. So let me write that. That is Avogadro number. So these are the number of atoms present in your 1 mole of NaCl. So that is it. And then when it comes to 1 gram and few more and the numericals, PYQs, we will definitely look into it in the next video coming up. Thank you so much for watching. Subscribe, follow more, and do not forget to click the bell icon. Thank you so much.